B.1, evaluate the polynomials. Yeah. So let's look at our first computing problem for this class. In this class, we will solve a sequence of computing problems. This is the first one, evaluate the polynomial. Look at the question first. Data. Data, it's a polynomial. P of x equals, so this expression, the standard form of a polynomial with coefficients a0, a1, dot, 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 an. So here, these n plus 1 coefficients, the data types, we assume real numbers. Okay, yeah. So when we do the computation to represent the real numbers, we use the floating point numbers. Floating point numbers. All right, yeah. So for this question, I select from section 6.5. Yeah. So here I can give you the reference, section 6.5 on page 234. The reason I jump to section 6.5 because I want to select an appropriate question for your programming project number 1, because we want to start our first programming project as soon as possible. And this is a good one. First, it is not very hard. So we can understand the details for solving this problem easily. But second, it's an interesting problem. So we can see the big difference when we compare different algorithms solving this problem. All right, Then, variable x can change every time. So the coefficients, after we select it, so we fix it for one particular polynomial. Then we can change the value for x, so we can calculate the values for the given polynomial. So now the question, how to evaluate P of x efficiently? So here, we know, everybody knows how to evaluate this polynomial. How to find this polynomial correctly. So everyone in this class, I believe you know it. But the question is, our main focus in this question is, we want to find it efficiently. That means the response time, the performance are very important. So if you find the correct result in a very slow way, people need to wait long time to see the answer, then it's not good. Then we don't want to use this algorithm. So we want to get an algorithm that can generate the correct result very fast. That's the goal. All right. So in our first try, we just want to find, no matter what method you can use, we just find one that solves this problem. The first try. So we do not expect to get an ideal solution in the first try. We just want to solve it in our first try. Okay, So here, let us use the straightforward algorithm. All right. So let's try in this way. First, we consider working on each term in the polynomial. Here, the typical representation of a term, a sub k times x to the kth power. This form. When we calculate the value of this term, we only need to do multiplications. So now we need to count the number of multiplications to find the value of this term. All right, so this is the first little computing problem to solve. So do counting. Now we need to do the counting. Here I'd like to introduce a simple but effective strategy to solve this little, small, mini problem. Yeah. So the strategy is we just do experiments to see some pattern, some rule, some property by experiments. Yeah. All right, so let's do some simple experiments. First, when k equals 1, let us calculate a sub 1 times x. X to the first, just the x. How many multiplications do we need here? Yeah, it's easy, it's 1. Okay? All right. Next experiment. When k equals 2, a2 times x squared. How many multiplications? Yeah. And not 3, because when you calculate x squared, you need 1 multiplication. X squared equals x times x. After that, you multiply the coefficient x2, so you need another multiplication. So 1 plus 1, the answer is 2 multiplications. Yep. All right. Can you see something? Yeah, after these 2 experiments, can you see something? Yeah. So if not, let's try another one. Yeah. Let's look at k equals 3. a3 times x cubed. How many multiplications? Yeah. First, x3, yeah, to get x cubed, we do x times x times x, 2 multiplications, right? Then we multiply another coefficient x a3, so total 3 multiplications. Yeah. So for k equals 3, the answer is 3. Is it enough after these 3 experiments? Is it enough to get a conclusion? How many multiplications we need to find this typical term? The conclusion. Yeah. Yeah. Answer is k. So here you can see, yeah, the simple strategy, yeah, very effective. Yeah. All right. Next, the question: is your algorithm efficient? Yeah. So you may. Yeah. So here, after we find the value of each term, then we just do additions. We add up all the n plus 1 terms. Then we can get a final result. Yeah. So we have no problem. We find a solution. But the question is this algorithm efficient? It may not be efficient, right? Yeah. All right, so here the question is, we may not know if it is efficient or not at this point, right? Yeah. Because this is the only algorithm we know to solve this problem. We have no other choices. This is the only one. How do we know it's good or not, right? If we have only one solution, how can we compare it with other options? No comparison, right? Yeah. So here, find the performance number of this algorithm. Yeah, so here, because in order to tell if this algorithm is efficient or not, there is another way. So people use, that's something called the performance measure. You need to define certain way to represent the performance measure. Yeah. But at this point, we are not ready to understand the concept of the performance measure. So we need to delay a little bit. Yeah. All right. So that performance number, so let us delay it sometime later. Yeah. Yeah. But not too much late. Yeah. Next question. Are we satisfied with the solution? Here we don't know because this is the only solution, right? This is the only solution. We cannot do any comparison. So we do not know how bad it is. If we have more than one solutions, then we can, after the comparison, we know which one is better, which one is worse. Yeah. So the first thing we want to look at, is it possible to get other solutions? If we see some hope to get a different solution, then we can try. Okay? Yeah. All right, so here let us consider the simplest case. So we try to do something different and hopefully to get a different outcome. Yeah. All right, so here let's consider x to the k. Yeah. So let's drop that coefficient part. Yeah. So we want to make things as simple as possible. Yeah. So this representation we call a monomial. Okay. Only one term, but we drop the coefficient. We only look at the power of x part, x to the kth. This to calculate the value of this representation, how many comparisons. Yeah. If we use our previous straightforward algorithm, yeah, because we can save one multiplication, we can save the last one. The last one, when we multiply the coefficient, that one can be saved. Yeah. So that means the k multiplications containing the ak coefficient, we can save one from there. So the number should be k minus 1 multiplication to calculate x to the kth power. Okay, all right, yeah. So that's the old method. Now we try to do something different, okay, and see if we can improve a little bit. Yeah. All right, so here I use a simple example. Yeah. So let's consider k equals 4, x to the 4th power function. Okay, all right. To calculate x to the 4th, let us do the calculation in these steps. First, we take one multiplication, x times x equals x squared. Okay. After this step, x squared, the value is known. It's a known value. That means we can use it again and again. Yeah. All right. So the next step, we do this calculation. X squared times x squared equals x to the 4th, right? Yep. That's all we need. X squared times x squared. We can get the answer, result we want immediately. Is it good? Is it much faster? Yeah. Yeah. In this way, the number of multiplications we need is 2. Yeah. But for this case, if we use the previous method, k minus 1, k is 4, 4 minus 1 is 3. You can see we compare these two numbers 3 and 2, they are different. And our new method, we reduce the number of multiplication by 1. That's an improvement. Okay? Although this improvement looks small, but at least it gives us hope. We can improve the first solution. So we have some good hope. Yeah. So next, we should try to improve from the first solution as much as we can. All right, yeah. So next, let's do some analysis work in order to improve this algorithm. All right, yeah. Do we really need an algorithm here? Yeah. Yes. Yeah. Although the first one is very simple, people may not treat it as an algorithm. Yeah. Actually, any sequence of steps, if you do the computation following a sequence of certain steps, it can be treated as an algorithm. Yeah. So this is not an issue. So here, actually what we need is a better algorithm. Yeah. Not just the algorithm, because any procedure, any step-by-step procedure or process, we treat it as an algorithm. Yeah. So we have to have an algorithm. Even if something is very simple, we need an algorithm, right? So here the question is, we need a much more efficient algorithm here. Yeah. All right, so then, so let's look at a little more understanding. When our imagination is very limited, yeah, so at the beginning, when we try to understand this particular question at the beginning, we do not have much experience, right? Yeah. And we need to build up our experience for better understanding of the given question. Yeah. All right. So then, how to build up the experience? Yeah. So here, one commonly used method, just like what we did in the previous slide, we apply the simplest algorithm to solve the given problem, and here we call it the brute force method. Brute force, straightforward brute force method. Yeah. Later in the next module, we will spend more time to understand the brute force method. Now here, the first time we see this terminology. Yeah. So when we solve a problem without using any particular technique, yeah, just using the trivial operations, yeah, so without any special technique, so we call it the brute force method. If you need to use some special technique to improve the efficiency, then we do not call it. So, because if your technique is non-trivial, yeah, it takes some effort to discover non-trivial, so then we do not call it the brute force method. Here, the method in the previous slide, we can call it the brute force method because we do not use any special technique. Yeah. All right. So here the point is, at the beginning of the problem solving, when we do not have much experience to understand the given question, so there is a typical way people use to build up the experience. So that is applying the brute force method. Try to see if we can get some interesting result. So during the calculation, because when you work on it, you need to do the basic calculations. When you work on it, so you can understand the problem better and better. And you can discover more and more properties. So that process we treat as understanding the problem. When you have better understanding of the given problem, then you have better chance to solve it more efficiently. All right, so let's complete our first lecture right here. Next time, we will complete this whole topic first. B.1, evaluate the polynomial efficiently. The whole topic at the beginning of our Wednesday's second lecture. All right.